exactly what we're doing. Can I actually get a link? Channel live. Live. Really, I'm already live. Go. Should already be live. Let's share this. Okay, so streaming. Close. I don't have. Need a moderator. All right. So we're going. So I've already just set up the file. We're going to be recreating this effect here. There's a few issues that I saw, and I'm just going to go over do basically. But starting out, what we're going to do is we're going to figure out exactly how this is all made. Looks like it's just a simple source particle thing, basically using a solver. Why my computer is being really slow today. It's from here. Okay. So this is the file I've got. I've already got. You can that because I'm not going to need any Python. Hope. Let's start out by making a source volume, source section, post, save, and I'm just going to call this. All right. So you're just scaling it in. What I'm going to do is I'm going to bring in the dragon. Don't know why it's being nice and slow today. Put on the VGO. Here. Nice and slow. Where is it? It is not where I want it to be. You actually want to center it. So how do I what's the best way to center this? Well, first of all, I'm going to scale it. Transform, scale. Let's scale it down to 1. So before I do that, I'm going to center it. So where's the center? If I lay down a sphere, I mouse over that. I don't really see it. There it is. So I want to center it there. So the easiest way is to do the HScript components, which is a $sign and then CEX. CEX for centroid X component. You'll see that's moved it across. So I want to move it the other way, so I'm going to negate it. Now that's in the center in the middle there. We've got CE. I don't think I really want to center it in the middle here. So what I'll do instead is I'll push it to the minimum bounds, basically. What I'm going to do is I want to say CEZ here, though. I'm going to push it forward, so I want to negate that. Now that's kind of in the center. almost. It's not really in the center because this isn't really a perfect center thing here, because it's pushy. There's more on this side than on this side, really. So we're putting it into the center basically. This is just doing it programmatically. And I want to make sure that this is actually sitting on the bottom, so I'm just going to quickly push it up. And then I think it is VBox. No. Which one is it? So I want one of these. What was the VBox? VBox, yep. 0, and then dy size. And I think I either negate that or I get the minimum, dy min. And now that is sitting perfectly on the bottom. I can probably get rid of that. That is now sitting on the bottom, and I should be able to scale this down. The reason it's not scaling properly is because it's the translation's been put on first. I mean, the scale's been put on first, and then it's translating it down. So what I want to do is, I'm pretty sure I can pre-scale it using this. Go. Okay. Yeah. Dragon port. And I'm just going to put down a node. And I'm just going to call this dragon and color green. My stream's not doing too well in the sense of like the bitrate. Don't know why. Maybe because I've got like 100 tabs open. That might be why. Alright, so what I'm just going through the other file here. What we're doing is putting normals in, scattering in a ton of particles. So let's do that. Let's put down a facet node. Actually, I'll put the facet node up here. First compute it. We're going to do a scatter. Don't really want to have the relaxed iterations on, so that's going to be nice and fast. And then we have about 500,000. I think that's 500,000 points scattered on the base. Merging that. So, and now then do is I want to do a VDB as well and scatter in points in there. Merge that. VDB for polygons. Push it out. I'm going to turn off this. Going to put on density, and then I'm going to say fill interior. Now we're going to get polygons points in there. I'm going to switch over from the point display to a pixel display. And then in the scatter, I'm going to put it to about 2 million. I think that's right. Yeah, 2 million. And we're going to increase this, the max that we can have, about 4. All right, so now we have 2 million points. We've got about 2.5 million points now. And what you're doing is you're making a making a group. You're setting it to points. What we can do specifically is we can make 2 spheres. This is a nice easy way of doing it. Instead of having to do, I'm going to go polygon, put this up. I'm going to make 2 spheres. I can transform them both, but I can transform them here too. I'm going to say group. And I think if you click on the 2, press the output, and then press and hold Alt, and then click, you can make a merge node. Thank you, Urban. He was the one who told me that. We're going to say inner. I'm actually going to call my grouper name. Going to change over to points so that we actually are getting points in there. Going to change it to bounding regions, and in bounding regions, I'm then going to say bounding object. Bounding object should be getting into points. Interesting that this is a new one, bounding hull. I haven't actually seen this one before. I'm pretty sure it should be bounding object. Might be the fact that it's not fully encapsulated. So I'm going to then copy over the ones that he had. So I'm also going to set this to 111. Oh, I see. It's killing it because there's two spheres here. Okay. All right. Just copying them over. So the reason it's not quite doing it there is because his is in the center, mine's not. So I will adjust it properly. So where is his actually living? His is on the edge. I don't know why his is so small. Mine is a lot larger than his. What's his transform? Is it 0.1? What's my transform? My transform should be at 0.1. Yep, okay. Don't know why, but his looks a bit different. That's fine. I'm going to move this one up so that we are actually getting the tip of that. And then I'm going to move this one up as well. And a little bit over. A bit more. There we go. Okay. Then you're making a noise, and then you're doing a distance from geometry, which I haven't seen. Yeah, I haven't seen this one used for quite a while. And it looks like you're using an old version. This. Interesting. Points. Yes, this is an old one. Let's go. Now I'm going to, the way I'm going to figure this out is I'm going to go to show an asset manager. This is a distance from geometry. Am I getting distance along geometry? Am I? Oh yeah, that would be why. All right, that was my mistake there. Grab that. Oops, nope, it wants to be on here instead. This distance along geometry, I want to get inner points, and we're outputting to group. I can just like guess, but I will put points here as well. And you're also doing like an attribute noise to just noise it out. Should do the same. Copying over pretty much the same values that you're using. So you're doing pseudo-centered, you have got it on that almost 2% there, and you have no fractal or warping going on. Okay, and then you're just doing an attribute copy. Yeah, I will keep it to the attribute copy. I was going to show Vex, but for time, I won't. My streams tend to go for a very, very, very long time. So I'd rather not. I'd rather go to bed early tonight. Thank you. So attribute copy. We're just going to copy over the list. CD. Right. then you're doing like a point bop, which I will believe is visualizing the distance field. So let's grab that. So actually, no, you're not. You are doing something different, something completely different. That's actually nice. So let's recreate it. Side here, we've got two noises. Curve noise, curve noise. Plug that into there. We are fit ranging it. Fit range the output for both of them. So this is 0.8 and 15 to 0. This one is 0.4 from 260 to 100. Right, so let us visualize that. Both this, this, which we're not really seeing anything here. So let's change some of these. So for the alligator, at least, I don't for this one. This is going to be set to alligator. Amplitude is set to 5. That's quite harsh. And you're turning down the roughness a bit. Okay. And then this one does it. You have set it to sparse. You've kept that to 1. You set the offset off a little bit. About 2. You set this back to 5. Don't really agree with. And this is about 3.5. So we're not really seeing a lot there in terms of well, anything. Well, that's because it's 60 to 100. Okay, that's why. Because we're not seeing like a 0 to 1 range. So if I put it back down to 0, we're going to see it. I'm not too sure why you're doing that, honestly. That is quite a high value. But regardless, let us carry on with it. So let's go adding in the distance. Plug it into there. And we're going to fit range this as well. I can just copy this, can't I? Press and hold Alt to that. This, you've got 0 and 7. And negative 10. Interesting. And then we're doing one more fit range. Goes here, and that's just going in from the source min here. And you are going to be about 20, between 0 and 1. Interesting how I'm not getting the same result as you. Would help that we actually have to add in the frame as well. That might help, you know. Adding in the frame might just help. There we go. And you're outputting that to a new attribute called mix. Give me a moment. I need to have a Panadol. Whee! Okay. Right. Right, so now we're storing the rest. We're making like a new rest position for us. So I'm going to say transform. This is going to make us anim noise. We've got a transform here, which we are pushing out to about 15. Really, I'm going to wireframe this so we can see it. And you're pushing it up a little bit to the right, and you're scaling it. 4, 2, 6. Sorry, that's rotating it. My bad. You are scaling it though. Now, let me know, anybody, if this is not helpful. We're going to go rest position. All that rest. But before we do that, we're going to add some noise. Patch of noise. And you've got quite a few noises going on here. So you've got a position. Your amplitude is about 8.5. 0 centered as well. You've got this to be about 0.32. Offset should technically have an animation thing going on. However, I will keep to what is going on here. 30. I would suggest 30 is the 30 should really be the frame, the what do you call it, the FPS, but it's not. We go that divided by FPS, then we're going to say that, okay, 24 is now 1. Okay, and you don't have any fractal. I think that was almost it, so I'm going to add another one. This one, instead of a simplex, is a sparse. This is about 3.75. And instead of this, you're actually multiplying it by 2. So I'm going to multiply by 2 as well. And this is a bit less. About 5.8. And I think you still have a bit of a fractal going on anyway. Okay. And you're just doing that to the rest. And then finally, we're giving points at ID. So I at ID equals at point. So ID. Now, just to be careful, ID, when you bring this into the pop sim, the ID just dies. It gets rid of the ID. So I'm going to call it. So I guess I'm going to say point ID, PID, instead of ID, because otherwise it's just going to be really annoying and it's not going to work. Okay, let us take a look at what you've got going on. The rest of this stuff. So you're doing a blast if the points are less than whatever that is. Great. That. So what I'm actually going to do is instead, I don't know if any of these are actually being used, but what I will, apart from the obvious the blast part there, but you are doing an attribute transfer of like n. Don't know why the n hasn't been transferred anyway. Let's see if it actually makes a difference. It shouldn't. I'm going to transfer the n. Yeah, okay. It makes a difference. We'll transfer it then. And then you're making a point velocity from the noise from that attribute. Okay. So that's why. So point velocity. There probably is better ways of doing that, but for now we'll keep this. Does this have a UV? No, it doesn't have a UV. Okay. I was going to show a way for it it for UVs, but for now we won't bother with that because that's a bit advanced. Right. What's this question? Uh, someone's asked. Kermit. I wanted to say Kermit. I'm sorry. Asked about SOPs, the vellum grains in SOPs and outside of SOPs. So the reason that they're trying to bring it more into SOPs is because they're trying to make it more artist friendly than technical friendly, which means that it's very much what we call a black box, where you plug in, you basically have this one node that does everything that you want it to do, and it's super helpful for artists when they're just trying to start out making something to give the client as a test render. So like if they're doing an explosion, they can whip up a quick explosion in that, and then later on they can go in to the actual thing, into the the node itself later on, and make a more advanced version if they need it. But it's very much a black box in the sense that it's a preset basically. The second advantage is that means it doesn't have to, you don't have to import from the DOP network anymore, which I don't know why that's an issue, but some people have issues with that. What else? There's, I believe you've got the bullet one as well, the RBD bullet solver. So as you can see, it's actually going to bring out a lot of different things as well. It's going to bring out the proxy. It's going to bring out the simulation points if we need it. It's going to bring out the geometry if we need it. It's actually going to do all that under the hood. If I unlock it, we can see that it's going to get the geometry. It's coming in from the transform pieces here. It's going to get the sim points, which is just coming directly from a DOP import itself. Same thing for the proxy, but that's going to be using a different geometry if a geometry has been specified for like the proxy here. We use proxies in the simulation itself and high res for the render, obviously. The same thing would be, it would be the same for like a Valium solver. So if I go to the Valium solver and I allow editing, the Valium solver is probably pretty good to be able to use in SOPs, honestly. But for the purposes of the whatever Saber's teaching you, because I haven't actually viewed these lessons, go for it. We're compute from attribute, and we're attributing it from the normal. Continue on from where it was. See why you're bringing in the normal. And you're adding a kill noise. I'm just going to visualize this now. Turn that off. We're going to see it's going to come out that animated yet, and you put it up to be about 0.79. That's pretty much the only change you've done. Okay, and then we just we're caching it, so I'm going to do file cache as well. And I'm only going to go for about the same as you, 160 frames. Apply file cache. So this is going to be source point source here. I want it to go to the sims. No, yeah, sim. I want to go. Yeah, I do want to go to the sim. Okay. And it's going to be the point source. If I want to take a look at what it's going to look like, then we're going to see it's like this. It's going to be point source, version 1, point source. I don't know if I'm going to be using versions on this, so I am just going to get rid of the versions. That means it doesn't have intermediate. Would have point source version 1, and then this thing. I'm just going to get rid of that one more folder in there. Load from disk, turn it on, and then cache. We'll let it cache out. Now realizing I can't pause the stream. It's been quite a while. So now we've got this. I'm going to go null. I'm going to say out point source, and I'm going to color it gray. Be it, and I'm just going to go geo new one, and this is going to be the Sims folder. All right. So going to go hide other objects. I'm going to then go object merge and bring that in. Get that off. All right. You are using a time shift, and you're upping it by about 15, so that I would say the thing starts sooner. I'll probably make it start even sooner than that, honestly, if I'm, you know. Oh no, I was looking at the wrong. My bad. I'll probably started. No, 15 is good. Okay. Now then, what we want to do is we want to create a source. Easiest way to do that, which isn't 100% what I would do, but the easiest way to do that would be to, and it's been quite a while since I've had to do like a smoke sim and stuff, but I will show you the way I would do it. So let's make a .NET, and it's going to be the smoke sim. I'm going to color it red because I like to have my, if it's anything to do with like fire or smoke, I color it red, that type of red. And with a pop network, so if I go popnet, I tend to color this a nice blue. That's just my personal preference. Okay, I'm just going to dive into your smoke sim and to see what we have going on here. It's freezing. That's not a good sign. Okay, there we go. So you've got one smoke source coming in, you've got a smoke source sparse, you have got object, and then you've got some gravity and ground. So I believe we've discussed the ground floor issue before. I'm not going to use the ground floor, so I'm going to go smoke sparse, smoke solver, smoke object. Plug these two in. See that come up. I'm going to say close below 0. I'm going to keep it to 0.1 for now. And you've got two sources coming in, but you're using the wrong ones. That's fine. So what I'm going to do is let's start out by making the source. Oh, so well, first of all, we're blasting out all the points that aren't like that. So I'm going to go attribute wrangle. Actually, I will just use the blast. I'm going to try and steer clear of X because I get lots of X quite easily. That cd.x is less than 0.5. This is under points. Okay. Then we've got two wrangles here, one seen, not seen. So what I'm going to do is I really don't want to do that. So let's go time shift. I'm going to see if I can just copy it like that. Time shift is -5. And what it's doing is it's overwriting the value if it's seeing it. So it's getting the middle point basically. Do there then is I can say, hey, is if let me see, find, I think it's find attrib val, yep, find attrib val of 1. So string, so we've got geometry, which is going to be 1. String attribute class is going to be point. String attribute name is going to be PID. The value is going to be PID and that. So 1 point ID. I think that was it. That wasn't it, was it? Find attribute val. That's quite handy, this thing. String attribute name and then value. Right, so I want to say ID here. Now then, int point. Now then, the point should give us, so if I go at cd equals point, we should hopefully get some ones that are just black, technically. So I want to say PID, because we've changed that, remember? There we go. And now the ones that are in black, because this is going to give us like a -1 if it can't find it. So I'm going to say if at if point is equal to at -1, keep doing that, then remove point. That's going to give us rid of that. So I actually want it to equal -1. Now we're getting the insides section there. Wrong with you? And click cast. I need to say I. So now it's happy now. And now we're getting the insides points. So get inner. That's just a trick that I like to use, which is the find attribute count. So it basically finds an integer of the same type and tries to get that for it. Another one would be ID to point, I believe. So let's grab that. Do that one. So in point is ID to point, and then I'm going to say, however, I believe it actually does need to be an ID. So if we go 1 I at PID, it'll just all be 0 basically. Yeah. Okay. This is the one we want. Now that we've got that, what I need to do is I need to make VDB. This is for this, I believe. What I want to do now is I want to have one VDB. So I got that to you, and this one can just be made from that. Yes, I think so. Interestingly enough, all right, no, yeah, okay, no, that's right. So what I'm going to do is I'm actually going to split it. Split between this. Let's say set points. Now we're going to get one side is going to be 1, the other side is going to be the other side. And which means that I'm going to invert the selection because I want this one to be the volume blob. Let's take a look at what you're using as a source of the smoke. You're just doing a VDB from particles. Fine. What I'm going to do here is there's 2 ways we can make a VDB specifically. I will show that the best way, obviously, is from VDB from particles, which will make this. It's not great. Let's put that at 0.05. I'm going to turn off that there. I'm going to set this to about 0, and this one to be about 0.06 as well. And now we're getting this. It tends to be quite fast. Not all the time, but it is quite good. So there's another one which is particle VDB from particle fluid, which is just going to give us something more like this. So, well, not quite what we want. So let's go. Particle separation is going to be 0.06 like the other one. The influence and the droplet scale. So if I turn on this, then it's going to be like that. So if I go 1.5, it's the same thing as like this. So if I go 0.2, the droplet scale is going to get nice and small. This is quite good for getting really thin, wispy smoke, honestly, is getting this down right. We're not going to use it. It's not really what we want. One more thing that we can do, which is very advanced, this is a method that I've had to use in some cases, some very special cases. What we do is we do bound. This is quite hard to do actually. A bounding box. We do VDB, and I'm going to call this one density. The voxel size is going to, I'm going to keep it to about 0.01. I'm going to say VDB activate, and then I'm going to say by reference, and now we're going to fill that up. I don't want to actually fill it with a value, but now all these voxels are now active, and it's not a great thing to have them all active, let's be honest, because it means it's going to be using a lot more memory. But in some special cases, I've had to use this. Then what I do is I make a volume wrangle, plug that into here, plug this into here like so, and then what I do is I do a point cloud lookup. So I go int PC equals PC open 1 P at P, channel floats radius, channel I point max points. I'm going to enable that. I'm just going to give it points, and now I'm going to say if PC num found PC is greater than 0. So if there's more, if it finds more than 1 point, do this. I'm going to say if at density equals 1. You can see it doesn't look quite good. So there's some fancy tricks that we can use to kind of mask it and to keep it looking nicer. But this is a kind of a trick that I've had to use in the past, because what it does is it fills out the voxels completely. Not really what we want, especially if I want this to be like 0.5. It'll look a bit better, but it also looks quite full. Okay, so that was just something I wanted to show you. The VDB from particles, we've got this. This is the volume. What I'm then going to do is I'm going to make another one. And I'm going to, instead of say density, I'm going to say distance field. I'm going to keep that. Honestly, I'll keep it to a point. I'm going to keep this to about 0.2. And I'm going to keep these the same. It doesn't matter how good the source. I mean, no, it matters how good the source is. You know, the source should be nice and good when it comes to this sort of thing. You'll see that there are some points that just look odd, even though there shouldn't be really any points there. These points look quite odd. So let's try and figure out why that is. Shouldn't look like that. I don't like it looking like that. I think some of the points are off. They shouldn't be. Should be quite nicely there. For some reason, that's not looking very nice, is it? So I think I did this in the video last time, didn't I? I think so. Yeah. Okay. So what we're going to do for the collision, I'm going to. I think it was this one that I wanted anyway. Yep. So in the collision, for the collision, I'll show, because you weren't the file did not actually have a correct collision. So I'm going to then go file. No, I actually want to go object merge, and open. I'm going to say source, DragonFade. Bring that in. I'm going to do a VDB from polygons. I'm going to set it to about the same as this. We're getting quite a nice BDB. I'm going to turn this off and go and check it to density. I'm going to say fill interior, please. Doesn't look quite nice, does it? Then we've got a volume but I'm just going to use a wrangle. Volume wrangle. They're different to an attribute wrangle, just so you know. Bring that in here. Bring it in over here. Here's the volume wrangle. If I just take a quick look at the VOP here, I can quickly deduce what it needs. It needs a sample field. So let's say I actually don't need to bring in a sample field because I'm just going to be writing directly to density. So f at density, okay, multiply equals 0, and that's just going to kill it basically. What I want to do is I want to say int points equals len PC find. I need to make this an array by putting those little square brackets in front of it. I need to say PC find 1 p at p. I'm going to just hard code these values. So I'm going to say 0.1 and 10 for the amount of points. So the 0.1 is the radius, and that is the amount of points it's going to get. And then I'm going to say len of points. If I go like that, then nothing's really going to happen. And what I want to do, what I can actually do, is instead of going len of points, I can, well, it would help if I actually was bringing the points, wouldn't it? It is kind of working, but it's also multiplying it based on the length. So what I want to do is I want to say, I think it's that. Then we do a question mark 0 colon 1, or is it the other way around? 1 0. Yes, it's 1 0. All right. So what that does is it's a quick if statement. It's saying if len of points. Okay. So if I say is less than or equal to 0. That'll be why. That's why. Okay, so 0 and then if len of points is less than or equal to 0, then give it 0, else give it 1. That is what the statement's doing there. And this section here, what this means, this little asterisk equals means, what it does, it means density equals f at density times what's after this. That's what that little this does. This means. All right. Now that we've got that, I'm going to use this as my source, my smoke source. No, do I want to? Can't remember if I do. I can, but it'll be easier. We're going to be using this as collision. Cold wall. Yeah, cold wall. I'm going to make another one of these. No, hang on. Yeah, this is the one I want. I'm not doing too well today, obviously. You seem to be making the volume noise texture as well. So let's do that. So inside here, I'm going to say name. And for the name, what we're going to do is we're just going to rename density, basically, I believe. Number of namings, number of renames. We'll go like this. Density. Yeah, it's not going to give us what we want, so we want to say renames as well. So I'm going to say density, temperature. We should be getting that as well. Density. And that's just going to give us that. Second, we're just renaming this. I don't think we need that. There, we just need renames. You are doing a volume noise fog. Interesting choice. you are using the temperature, and in here you are doing a zero valued 2.4 roughly, 1.3, and you're animating the noise. Okay, you're merging it, and then that is the source for smoke. So go null out source smoke. Rename that smoke source, and I'll file cache this as well. I'm gonna keep not versioning it because I don't really need to. Load from disk. I'm going to save to disk. I love it. The average view time of this video is a minute. Oh, that's brilliant. Okay. So that's done. I don't tend to rename these. Let's go into here. Let's start making a source volume. Sources, no sources. There we go. Volume source. I am just going to plug them in. Density into density. Temperature into temperature. See, are you changing any of the values? Nope. And I'm also going to enlarge this as well. Okay, if I just set that off, see that working. Looks good. But I'm going to put on gravity. Well, and I'm going to turn that down quite a bit. In the actual smoke solver itself, we're going to change the buoyancy. The temperature diffusion to 0.2, 0.7. That's it's already got gravity. Okay, I don't know why we're adding another gravity to it. If I turn off this gravity here, looking relatively alright. Alright, so then you've got some turbulence noise. Let's go merge. Let's make two gas turbulence noises. One of them should be the min, one should be, so this one's big, this one's maps and min. you're getting a dissipate, and finally a buoyancy. Never spell that right. Let's focus on this one first. So you got 0, 1. So this is just going to basically push it over. I'm correct. Yep. Another thing we can do is we can actually make so if I go VDB from particles, let's go VDB from here. Let's take a look at this has got a velocity to it. I can actually say, hey, point attributes v, and call it vel, set it to you this, and then I'll just we'll recache that out. Who's helping? Okay. The embed. Got to eat today. Good fun. We got to eat and then went to the gym. Not very bright. Right. So if we take a look, I'm going to quickly take a look at my source now. We're going to see something a bit different. Going to look a bit weird. This is the velocity field. Let's actually view it inside here. Cut all these, and let's add the velocity field. Devel. It is a vector field. You can see it's kind of behaving a bit randomly, a bit weird, and not really what we'd like. So what I like to do is set my own. Even though we've got the velocity field here now, and it's got values, I'm going to set my own. So what I'm going to do is I'm going to grab you, first of all. I'm going to grab you. I'm going to go scatter. To relax those iterations, going to 10,000 points. I'm going to do something called a volume trail. Inside the volume trail, we're going to select the points, and then we're going to select it here. Then I'm going to say I want to see the velocity, and we're seeing this is the velocity here. What I like to do after that is mess around with it. So I'm going to do volume pop. Whoops, no, I actually want to view this. What I'm going to do is I'm going to do bind export. Do val. It is a free floats vector. These free floats vector and vector are the exact same. You don't need to worry about that. I'm going to do a const. I'm going to do a parameter. This is going to be a direction, wind, dirt. So I am going to make it free floats vector as well. Plug that in. Go back up. One. This should be outputting it to val. It is for some reason not updating it. Because how are we getting two val fields? Why are there two val fields? Because of this. Alright, so I'm going to blast out the second val point. Second val one, which is really annoying. I'm going to go blast here. And to say, go to you. I want to get rid of val. But this is also here as well. No, I will actually recache it out. So we're waiting for the cache once more. It should go a little bit faster this time. The hardest part here is not so much creating the VDB, but actually just writing it to the disk. Writing it to the disk can actually take the longest time. Even though I have got an SSD installed, that's what I'm using, it can take a bit to actually write out to the disk. This is why we use a VDB, because the VDB does not, even though it has like a bounding box, it is actually not using the entire bounding box. It's actually making tiny little bounding boxes around the geometry. So you'll see that some of these, when I view it in a tree mode, you will see that the majority of them will have like little boxes, and those boxes are what are actually active and turned on, and that is what is going to be saved. Meaning that we save memory when it comes to doing this, and we save memory when we're writing it to the disk. Okay. And now, when I'm actually doing it, you're actually going to see that I'm actually changing it. Okay. Right, come back in here. What we're going to do is we're going to make a noise. I think I want... Which one is it? I hope it's not a unified noise. Unified noise is probably the one thing that's the slowest noise there is. In here, I want a curl noise. Curl noise. So we've got a flow noise and we've got a curl noise. A curl noise. And what we can do here is I can add it. So get the position first. Now you can see it's making a lovely little core noise. I can do the same thing here. Position. This is quite a nice one to work with, really. However, let's promote that and let's see what the flow does. Doesn't really do much. So ideally, the best one to work with is actually the kill noise. But I don't want it to be too harsh, so I'm going to put it down to about 0.4, 0.2, and I'm going to set it. And the more I pull it down, the less it's going to be affecting on that. So if I just set it like this, if I'm going to set the frequency down, nope, I want it to be about maybe 0.4. What I can do is I can do parameter. I can say frequency, so frequency. I can then plug that directly to there. And that should update all the values. Okay. Now, if I jump into here, kill that for now. You're going to see that it's kind of pushing it out in that direction. If I set this to higher, then it's going to push it out even further. But what we're going to do is we're going to make use of that buoyancy to make it kind of like spin around, because we actually want it to go the other way. So if I go and I view the temperature, actually let's go multi-field. Then multi-field, we want density and density. If I select density, it's going to have like a little bit of a shading effect. Not quite what we want. Say temperature. Yeah, if I can spell it right. I'm going to, okay, it's got a physical black body. Kind of what we want. What I can actually do is, instead of physical, I can just say clamped, just say clamp range. And then here I can say black body. Not going to look very nice. Black to orange is a lot nicer. Except I do want this to be a bit darker red. And then I can just set this one to be a brighter white. But push this kind of real close there. And then I can copy this. And this is going to be like the effect of that. So now we're going to see the total of this. All right. I'm going to set this to 1. And I'm going to plug in just the gas buoyancy to see how this looks. Ideally, start off like this, and it would actually, so which way is it going? Negative V. I actually might want to go V. Nope, it's going the right way. But I do want it to be negative. But the gas buoyancy, I'm going to set it to be 8. So it kind of like moves around in on itself. if that makes sense. And when we add the collision, you'll see why. You'll also note that the density is kind of doing that too, which is all right. I can literally just set temperature and density to the I can just set the density to the temperature, and then it won't have that lingering field there. If I set this to maybe 2, this is typically set to 1.5. What I want to do is I'm going to add the dissipate here, which is around, I think it's like 0.6 was the diffusion rate. Let's take a look at the other one. Gas dissipate, was it? Oh no, 0.6 here. This was at 0. Okay. Nope, that's not what I want. Right now, what I do want to have, before I add anything else, is the what's what I want? I want the collision field. So let's add the collision field. Right, so collision field, what we want is, does not really have a density or a velocity or anything like that. We're going to have to make our own. Easiest thing to do, though, which is create here. I'm going to create a surface distance field. So this is our collision. This is going to be our collision. Yeah, this is our collision. And I'm then going to go VDB convert. I'm going to convert this from VDB from log to SDF. I'm going to set this to rule low. 0.5. It's going to have some little floating pieces, which I don't really agree with. That's because of the point. Anyway, but what I want to do is I want to add in the normal field. So I'm going to say surface attributes. Turn this off. I'm going to say point n, and I'm going to say velocity. This is going to be a gradient normal. No. This is going to be a displacement normal. What I can actually do, because then what this will then generate, if I go here and I grab these two pieces again, so we can actually view what is going on. So scatter it onto here, bring it to here. What I want to view is the velocity. Again, let's see, this is the gradient here. If you want a different gradient, what we can do is you can say VDB analysis. We need to go here like that, plug it in here, and I'm going to say gradient scalar vector. I'm going to say custom name. I'm going to call it vel, and now that is our velocity that we want out of it. You'll see it kind of looks very similar, except it's just the wrong way. It's the different way around. I'm going to keep that one instead. This. Because we can actually set it to this here under the collision as well. We can see that it's actually making collision based on that. So what I'm going to do is I'm going to merge that in, and this is going to be our out smoke hole. Do the same one here. Collision hole. And we are now getting our collision. So the only problem is the name's going to be wrong, but that's fine. So I'm actually video val and density. That is fine. I'll show you what to do, because you get the reason why it wasn't working last time is the names were wrong. I'm just going to quickly cache this one out. If any luck, this will be a little bit faster. Just mute myself. Okay, that is done. Smoked collision. I'm going to plug it into, whoops, no, I'm going to plug it into here, my bad. Dive in. This is our smoke. What we're going to do is we want to make sure that our collision is being made. So I'm also going to say, show me collisions. This is going to be a collision. And inside here, what we need to do is, instead of density, I'm going to say collision. I say second input. Not going to show up, obviously. I'm going to say the maximum, -1, because this is an SDF field. Also going to merge this. And see it's kind of showing up here. Wait. I've accidentally locked it, I believe. Haven't? Good. -1, yep. Collision, collision. Yes, 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 yes. And then we're going to say V. It's going to be into collision vel. I mean, so yeah, vel. It's going to be into collision vel. Finally, I think I need to go into smoke solver itself and collisions, and I'm going to turn off collisions fields to correct this and temperature. Pick it up. I love it when it works, don't you? It's so nice when it just works. So this is obviously wrong. I need to figure out why it's wrong. So at least vector first. Still wrong. Just use the temperature instead. Interesting. Interesting why it's not working properly. Let me do VDB erode. Even though that should not do anything. So VDB reshape. I'm going to reshape just the density, and I'm going to say erode by about 0.5. I want to erode it too much. Not too sure why it is not giving me a proper collision. So should be giving me a right collision. Not. Build collision mask, that shouldn't need it. Let's just make a new volume source. Let's just say collision. Don't know why it wouldn't work like this. Second input, density, and val. Still not really working how I'd like it to be. So let's go to you. Say kill that, turn off that. I'm just going to plug it in like that, and I want to make sure that my collision is actually getting read in properly. It's not. Why not? That's surface. let's go to surface again. Surface, surface. Interesting that it's not actually giving me a proper collision geometry. That is very unusual. Even when it's fully there, it's not actually giving me a proper collision geometry. Turn you off. See, it's working on the other scene that I'm using, which is incredibly annoying. Because I don't know why it's not working here, but it is not. That is incredibly frustrating. Collisions, yep, collisions is correct. Yes, that's correct. Turn you back on. Better not be because of that. Not. The collision is obviously wrong because it's actually giving me like a very thin one. So fill interior. That better not have been it. That was it. The fact that it wasn't filled. If I got this and I just turn off the collision, it is actually bringing it in there because this is not being done right. So you should be right though. So let's take a look at the U. Let's do a volume slice. Volume slice. I just want to slice the density. Oops. Overview. Plug you in. Why isn't it liking this one? I want to view the collision, please. Yes, so density, what it should be called. And I'm not seeing any collision whatsoever. Where is my collision gone? Well, it would help if I wasn't using a volume slice, wouldn't it? Intriguing. Why is it doing that? This is the joy of doing it live, is that you muck up and you don't know what the hell is going wrong. Last, the velocity. Don't think that has anything to do with it, to be honest. You know, you try everything you can. It's kind of like not feeling it properly. It's almost as though that it is not completely filled. So if I go to U, I go volume, wrangle, I go V, I go F at density equals 1. I have now filled that completely. It's going to be very bumpy, but it's now filled. Menu off, just going to calculate it manually. Still not liking it. Okay. How unusual. So let's try this again. Got a volume slice. Let's go -1. So that which is at 0 is the minimum point, and -1 is the maximum point, basically, or how far away it is. So we can get, like, if we go 0 to 0.1, then we get the total range. What we can then do is, if I grab you again, so surface, we can see it's kind of eating that then away. But that does mean then that which is closer is so not eaten. So what I'm going to do is, instead of that, I'm just going to say len of those points that's found, which is going to give us this. I'm going to say invert that. 1 divided by len, sorry. If I then check that, I'm going to get something like looking like this. Not going to be correct though. Not correct whatsoever. So the easiest way of doing it without resorting to vex, easiest way is to get this VDB from particles section here, make a surface from that. I'm going to remove this entire thing. Except for this, I'm going to grab this one here, make a surface VDB, and fill the interior. I am then going to make a VDB from particles here. I am then going to say no to the density. I'm going to turn off the velocity. I'm going to say distance field again. I'm going to give us this. And then what I'm going to do is I can do a VDB combine. VDB combine. This is the last resort one, basically. What I can do is I can say copy, I can say VDB difference. I think it is one of these, not VDB union, CF difference. So what I want then, we're kind of growing it out, not quite really what I want. It's intersection. I want difference. There we go. Now we're getting the difference here. Problem is it's still giving us this. So what I like to do, this is where the VDB particles comes in here. And we're going to get a very, very blobby effect, but a much smoother effect. So I'm going to copy what is, so 0.2. Going to recompute it. I'm going to turn it off. I'm going to set it to maybe about 0.5. That's still nice and smooth. I'm going to put this about to 6. Now I'm going to set this to 2. And this to be about 0.4. Smaller. Then with the VDB combine, we get a difference, and we're getting this. I'm also going to go VDB dilate, reshape, and I'm just going to dilate it a bit. You'll notice though, this takes the longest time to calculate. So go to here, grab this one. You'll see that there is a distinct difference between the two. One of them is a lot faster. I'm going to set 0.7. Voxel scale to about 5.5. Influence scale to 1. So, okay. Then what I'm going to do is I'm going to do VDB analysis one more time. I don't think it works on a surface, so it needs me. I need to convert this from an SDF to a fog. I can then do a VDB analysis. That is now my val. Val. This is going to be surface. And then finally cache this out one more time after I merge it together. And that will be my smoke collision. I'm gonna do one more cache because the VDB particle fluid is the slowest node currently. Not that I like it, but it is. Hopefully I wasn't. Getting real tired. There we go. Now working properly. Good. Okay, cool. Gonna add in my collision val. 5 is a scalar vector. Large fields, yes please. And I'm going to turn it back on. Do one more check. Make sure it is using the collision. Yeah, it looks like it. Cool. And I'm going to do this. The solver works faster when you don't have to view it in the viewport. By the way, we'll tip there. It's a lot easier to just jump it to the section there. Okay. See, it's kind of pushing out behind the volume there. I'm going to put this, don't really need to put too much really. But what I will do is I'm going to show a quick trick. I turn that off. I'm going to put this to about 1.5, so it's a little bit faster. 0.2, honestly, so it's real nice and real fast. You're not really going to see much. What I'm going to do here is I'm going to talk about the this. So you have got the control field, stuff like that. If we plug that in, plug it in here, get rid of everything else. If I plug that in, we're not really going to see the turbulence too much in here. I'm going to set this maybe about 5, so we can actually see it working. There we go. We can see it's working. It's quite harsh. You got something called control field. Basically, it says how much is going to be put on there based on how if there's a lot of density, it's going to be quite big. So I'm going to put this to control field all the way up like that. So it's going to say like, okay, well, if there's a 1 of density, we're going to actually put a lot more turbulence there. But it doesn't look quite nice, does it? So what we're going to do is we're going to do a little trick. We're going to allow editing the contents. I'm going to set this to val. I'm going to make a note of it. It's called control field. Now then, this is in here. If I go into control field, noise type, nope, that's not the one I want. This one here is going to be called force scale. Dive into here, and force scale is what we want. And not really exactly what we want. So what I'm going to do is, because this is going to bring in a float, I'm going to say, nope, I don't want to bring in a float. I want to bring in a vector. And I'm then going to get the length of that vector. Because our velocity is a vector, and getting the length gives us the speed of our velocity. Go. Now using that, what we can do is I can set, hey, control min, let's go like 1 and then to 8. ideally, the faster it's going, the more turbulent it would get. Doesn't look to be what it's doing, does it? So I'm going to push this right up. And I'm actually going to set this to 0.1 again because we can't really see what's going on. 0 puts to 0.10. Now we can see it's not really doing anything now. It's getting a bit of turbulence in there. Not quite a lot. Let us take a snapshot of that just to make sure that our turbulence is actually doing something. And I'm just going to disconnect it. Disconnect it. This was going to 57, so let's go to 57 again. And we can see that it is actually affecting. So that's a quick trick that I like to use. I'm going to set this back to here, and I'm going to adjust based on what the other values were in the other hit file. In, you had it set it to about 0.5. Source scale of 1. You can actually visualize it if you want to. I'm going to copy this. Let's say I'm going to keep the value again, but this one I'm going to set to 0.1. 4. And I am going to set this to 5. Also going to go here, and I'm just going to make a small adjustment. Make that a B-spline, make that B-spline, B-spline. Then I can go a bit more like this. No, I don't want that. Something a bit more like that. I can go and copy that parameter, and I'm going to paste the values in. And I'm going to set this maybe 0.8. So, right. See handiwork. Not really seeing a lot, are we? But that's all right. So what I can do is I can set this to about 1, and that means it's going to the minimum is going to be given a lot more power overall. Go. Okay, let's bring in the gas dissipate. Let's bring in the gas buoyancy again. Taking its time to turn around, isn't it? So let us increase this. Also going to turn on the gravity again. Actually, before I do that, because I might not have enough memory here, 50,000. So about 50 gigs. And that's looking quite nice. Really. I'm going to set this back to 1. And I'm going to set this to be about 18 because it's not going fast enough for my liking. And then I'm going to put in the collision one more time. And let's see the entire range. Oops, that doesn't look too good. I think I've pushed the buoyancy a bit too much. Okay, I'm going to go back to 8. Push this back to 2. And then I'm just going to play with it, just so we can see it go. No questions? Nothing? Okay, cool. I think that's looking pretty good. Giving a bit more of a rolling effect, basically. And I think I didn't put the floor on. Very much a bit like code, honestly. You write some stuff and you think it's looking perfect, and then you realize no, it's actually not. Something's gone wrong, not looking quite not right, um, and you've mucked up your entire day. So that's kind of what I want. Not really. I'm going to put this back to about 12, and then I'm going to go close below, and I'm actually going to cash that out. But let us cash it out smartly. So you actually are using a oh, there's a pyro post process. I had no idea. That's nice. So dot import fields. Import that. The dot node is, oh gosh, what is it? Smoke object. Yep, that's the one. I want to bring in the density, temperature. Yes, but most importantly, I want the velocity. Okay. And I'm going to set both these to invisible because they are quite annoying. And then we've got a pyro. I didn't know we had a pyro post process that does this. That's actually really nice. So it's got to convert to VDB and actually converts everything there. We've got like a combined volumes, which is something we also do want to have. We've got to convert to a 16-bit float. That's really nice. You've got like a resample volumes section here. It's really, really nice. Because we didn't used to have this. What we used to do is, if I actually zoom out a little bit, here, we're getting all these. What we used to do is to go VDB convert. Come on, no, yeah, no. Wants to convert VDB. So here, convert to VDB. No change. We didn't need to change it. We need to do a VDB. Where is it? Should be a VDB combine, but it's not. Which one was it? Vector. Okay, so it's vector split. That's really not what we want. You want to say vector from scalar. Okay, so it used to be called vector merge. Now it's just called vector. So it's vector merge. All right. So then it's just going to give us this. The problem though is if we go tree, we activate it. You're going to see quite a few points there. So I'm going to turn it off. I'm going to say points. And if I say density, we're going to see the density. Very nice. If I say temperature, we're going to see the temperature. Very nice. Problem is if I went to velocity, we're going to see a lot of velocity. It's all around it. Not quite what we want. So what I'm going to do is I'm going to do a volume wrangle side here. I'm going to say VDB. So I'm going to say V at val. What I'm going to do is I'm going to say a float then is going to be F at density plus F at temperature. I'm going to clamp it. Between 0 and 1. Like that. Okay. Then what I want to do is I want to say V at val multiplied by, and we're going to do the exact same thing that we did up here with this wrangle. Except instead of len points, we're going to say den. Then we're going to say VDB activate. And I'm going to say deactivate. And I want to deactivate the velocity. Not working. So what we want to do is greater than 0. And now we're going to see that we're actually getting the velocity there. So what that's doing is it's deactivating some of the voxels so that we don't have to have all that there. All right, that's done. The problem that we may face with using this method is that the points may just stop. But that depends on the advection method that we're using with the pop advect from volumes. Okay, so I'm going to keep this one. I'm going to say file cache, cache. I'm going to switch. And I'm going to do smoke sim. So I'm going to keep it as the base name. I'm not going to say the hip name because it's stupid. But I am going to keep the version. Because I'm going to change the versions. We've got VDB activate, and then finally we've got a primitive. We have primitive properties, I think it is. Turn this on. I'm not going to do anything, but I'm going to go to volumes. I'm going to go to VDB. I'm going to say write 16-bit floats. That is doing this. It's doing here. Don't know about the resample. And the reason it's resampling is because the velocity isn't exactly always needed. So I am going to cache this. I now go out to the cache here and see we've got this is the smoke source. It'd be really nice if the folder would actually tell me the size. This is the smoke sim currently going out. So you got version 1. And it's the size is pretty small, which is pretty nice. I'm going to minimize this because it actually does affect some things. Let us take a quick look at the size. 600 megabytes. I'm going to save this. I'm going to switch it over. Switch it over to version 2. Actually, that one. But then if I switch it, it just switches with it. Not, I wouldn't use this honestly. I'm just doing it because of this specific one thing. I'm going to save it to disk again. It shouldn't need to resim because it's already in the memory. It's just going to write it out to the disk. Disk here, you can see it's out now writing out to the disk. Okay, let's look at the properties. It's about 0.9 gig. This is the difference here is mainly because of the resampling of the velocity. So let us also do that. Go let's go DDB resample. Resample the velocity. I want to say use voxel scale only, and we're going to say 2. Now, if we save that out, that should now be a lot smaller. Yeah, it's a lot smaller. About 400 megabytes. So it's up to you which one you want to use, honestly. Okay. Over to the pop sim part. I'm going to get rid of this. Whoops. Do I want to get rid of it? I do want to get rid of it. Yes, I get rid of that. This. I'm going to clean it up, make it look nicer. DB for polygons. Push this out here. Shape. Push this up a little bit so that's more in line. Bring these a bit closer in. Going to keep them in line though, as well as that, just because that's how I like to keep it. The volume up, I'm also going to push here. So add bell noise. Okay. Now what I can do is I can just take a look at that. Looking kind of cool. For some reason, that's just disappearing. Why is that just disappearing? Must be the points. The reason being is that the time shift is not actually doing anything past that. So we need to add 15 more points, 15 more to that for the time shift to work, because then, okay, so right, go back out to you, and you can see it's not actually working. So I'm going to say plus FF end plus a tail end of about 50 points, 50, just to be safe. And resave that out. Save time. I'm not going to redo this part here. What I'm going to do is I'm just going to when I go back, I'm going to just make sure that it's not reading from the same points. So merge. So we've got this that smoke source thing here. We can see it's kind of dying at about 141. Okay, 145. So I want to say from 145, and I say you delete that channel 145 and keep going. Save the disk. Okay, muted again. Let it save. So F start, back to there. And now that's looking good. Okay, over to you. 150. So you're kind of not really working how I want it to be, but you're kind of coming back in. So I'm going to say 145. Oops, nope. 145. Yep. Save to disk. Okay. I'm then going to quickly go back to here. Say F start, just so that it stays the same. Okay. With the smoke sim, do I really want to keep it going like that? Not really. I don't really want to recache this one, because it took quite a bit of time to make to sim. So I'm just going to leave it. Let's go to the pop sim part. This is the part that we're having a little trouble with, which is really annoying. So what I'm going to do is this in the inner. Let's just quickly go back to the reference one. The reference thing here. And this is the, okay, so this is literally just the out point source. Color it green. I color the other one green. Not. Didn't even put anything down there, so I'm going to say null. Out. Smoke. Sim. Green. So copy that. Pop that here. Drag that into the first input and dive in. Hit cancel on it. Come on, cancel. Top, first input, all points. There we are, we're getting some points. Very good. Not doing what we wanted to do though. So let's do a volume effect. Volume. Top, let's go here. The val is the val. I can actually just go out. So should be so. And that'll actually go, it's going to go up 2 levels, so it has to go out. So first of all, it has to go out of this level here, out of the node, then it has to go out of the DocNet, and then it can finally find the source sim. So instead of force, wrong with it, not tonight. I want to update the velocity. Set to you had it like trace midpoint. I'm going to set it like single step because I don't really, doesn't really matter, honestly. We're getting too many points for now. I don't really like that, so I'm going to time shift it by 2. So I want to get a lot less points just for visualization purposes. I'm also going to jump back up, get out, and I'm going to increase the cache rate to about 50. Go back in. All right, cool. So I want to do a pop drag as well. 0.1. Delete those channels. And then we're just going to quickly take a look at it. In my opinion, that's looking pretty nice. Where's that coming from? There's a little one coming right there. That's a bit cool. Okay, we've got that going. Got bindings, got inputs. What I want to do is I'm going to say turn off inherited velocity. Don't really want to use it. With birth, I'm going to say forward. I'm going to say matching. Not going to actually use a velocity. Doesn't really help too much. Life experience is about 3. So about 3 seconds. And then life variance about 0.2. Then round plane merge, and you aren't actually using any gravity. That's fine. But let's actually add some gravity. I'm also going to turn off this thing. Ah, how wonderful! Don't you just love it when something like this happens? Let's turn off the gravity. I don't think it's the gravity though that's actually affecting it. I think it is. It's the ground plane again, doing what it likes to do and just pushing the particles right up there like that, which is not what we wanted to do. But clearly, the particles are being spawned underneath it, so I'm going to say, hey, if at p.y is rate is less than or equal to 0, remove point. Just in case. I don't think it's going to do anything. The ground plane is being very annoying to me today. Physical, let's change that physical capabilities to 0.2, 0.1, 0.1, 0.6. I'm going to turn on display proxy geometry as well. Actually, before I do that, I'm going to say collision behavior, color hits. It's kind of hitting. Points are just being randomly made. How intriguing. I have a feeling there might actually be something wrong here with Houdini itself. Let's go to side effects there. Actual forums. Let's turn off that. Go to the support. Let's go to the changelog. Let us go to pops. Hang on, still doing it. Ain't that fun? Right, let's make our own one, our own advection. Get rid of you. Let's go wrangle, top wrangle. Oh, actually, before we do that, is it this? Turn off this interpolation. No, hang on. Put that back. If that's the reason, I'll be very annoyed. Looks like that was the flippin' reason. And I'm so angry. Let's switch that around. Okay. But now let's bring in the final one, which is, okay, so actually no, I want to bring in the drag. I'm going to bring in also a pop force, because I want to basically get this right. Pop force inside here, using it as like a bit of a wind, really. So I've got to -1, amplitude of 1, basically it. Okay. Good. I'm going to turn off color hits. I'm also going to turn off the guide. Okay. So jitter birth time, no. Interpolate source. I think the interpolation part is what's mucking us up. All right. Then I'm going to go ground. I'm going to say static object. Sorry. I'm going to merge. I don't really think I need anything here. So I'm just going to say none, no relationship. And inside here, what I'm going to do is I'm going to bring in the collisions. So this is the smoke collision here, which is a volume sample. They use deforming geometry. Not going to see anything, because we do actually need to have a stop from that. And I'm going to say out, pop. And inside here, I'm going to go convert BDB from volume to a polygon. And I can do the same thing here as I did last time. All right, cool. Okay, so let's just take a look inside here. It doesn't look as though this is actually updating, does it? Let's check the point source. No, point source is fine. Okay. I'm going to go back out to here, and I'm going to turn off the display of geometry. So I don't want to see it. Some points low do look like they're kind of being sprayed out. Let us add the color hits again. You can see they're being sprayed out a bit. Let's go slide like we have in the other one. And hit save. I'm going to go about 70 to 74 frames, and we're just going to sit and wait for that to be over. My Instagram is giving me a lot of Bocce the Rock memes, which I'm very happy about. Great series. Oh, it's also giving me Tomo Chan. Okay. And now Evangelion. Okay. Right. Okay. It's still scattering points along there, which I am not happy with, honestly. Um, it's sliding it along there, so that's not a good sign. So let's try and figure out how to get around this. I'm going to cut this. I'm going to go back to here. Come on. I am then going to actually cull these points quite a bit. So I want to get about 50% points. I'm going to say if rand at pt num greater than 0.9, then remove points. I think that should give me 10% of the points. No, give me 9. There we go. I want 10% points. Right, there we go. That's now going to give me 10% of the points. That's all I want. All right, let's jump into the popnet. Let's turn that off. Let's let it sim. It's really annoying that it's having to read in this. Affect it, but that's all right. We can deal with this. We can deal with that later. What I want to do is I want to affect how our geometry is being run. So I'm going to make a pop VOP. And what we're going to do is we're going to go back to here, and what we want to do is we want to say how deep is it. So I'm going to go to VDB volume where is it? VDB slice, volume slice. And if we remember when we did this slice before, and we set it to surface, if I go to -1 and to 0, then we get the full range. Kind of what we want, kind of close to what we want. Not quite what we want, but it is pretty dang close, isn't it? Okay, so what we want to do here is, I'll quickly show you in the wrangles. I'm going to grab, let's just grab the points. Object merge, just so we can see. There's our points, there's our volume. All right, so what I want to do is I want to do volume block, and I'm going to plug it into there. Oops, I want a point op, sorry. I don't want a volume block. So I'm not working with volumes, we're working with points. And I'm going to color these based on what the if they're in there or not. So I'm going to say volume sample. I'm going to say the second input. Primitive number is, let's go primitive name. We're going to say surface. Position is this current position, and let's just color that. Not what we want, so we're going to go fit range between -1 and 0 to 1. To 1, 0, like that. So I think that isn't correct. Basically, we want to see if it's in there or not. If it is, then push it out. So if it's in there, volume sample, yeah, volume value, surface, primitive name, second input, getting the surface, channel ramp, parameter please, like that. Let us infrared it. Go back to you. Not really what we want, so let us transform it a little bit. And we can see now that it's kind of getting in there. All right, cool. Great. Perfection. Now, if it's in there, so what we want to do is we want to say if it is not 0, better yet, what we can do is we can say if block, no, I can do a compare if it's 0, and I can plug it into there. You can see that it's not. All right, let us go to vector int to float. Int float. I don't think it'll make any difference. Now we can actually see that if it's inside it or not. If it's equal, or if it's less than or equal, or greater than or equal. If it's greater than or equal, then it's outside of it. If it's less than or equal, then it's inside of it. Okay, that's what we want to. That's all we want to say. All right. If it is greater than or equal to that, then we want to get to the closest point. So that would be velocity, which is that's the direction that we want to push it. So I then want to do like a compare, like an if block. Yeah. So if it's that, then I want to push. If it's that, then I want to actually push the position, add the position there in, out to the position like that, and I actually want to say volume sample here like that, and I'll push it in, and I want to get the velocity. That is not really giving me what I want, though, is it? This is saying it's a float. Right, so I want a volume sample vector. My bad. Wrong one. So I want to save second input. Primitive name is val. And we can see now it's actually trying to push it out a little bit. Not really what we want. So the best thing to do then is get our closest distance. Best way to do that is to make we go to here, do a scatter along the edges. At this time, instead of doing it like that, I'm going to relax it. I'm going to scatter that many points, maybe a bit more points than that. Okay, I'm going to bring that in. No. Okay, so what I want to do is color it that and say point. Okay, so I'm going to wrangle it. It's a lot easier if I just wrangle it for myself. All right, now if volume sample is less than or equal to 0, then that. So if I'm going to say float d for density, because that's just what I call it. I'm going to say volume sample 1 for the second input, surface, because that's what I'm getting. Attribute p, because that's the point, current position. If d is less than or equal to 0, then at cd is equal to set 100. It's going to set it's red. All right, now that it's red, what I want to do is I want to get the distance between the current point. I don't want to use a point open, PC open either. So what I'm going to do is go to distance along from geometry. Don't think this is the one we want. Go to distance, and we're going to see nothing on here. So what I'm going to do is I'm going to say if it's like that, then I want to say group at group inside if one. Now we're going to have a group inside, and I'm going to say inside. So, and our distance along the geometry is not giving me any. Might need to switch it around then. Nope. Okay. So we are actually going to have to use a distance, point distance here. So what I'm actually going to do, there is two methods that I can do because there's too many points on here. I don't want to get all the points. Actually, I don't want to do a UV unwrap every time, but let's just quickly take a look. The reason I'm talking about a UV unwrap is because we might need to use it later on. Let me take a look. UV quick shade. Kind of doing it. Not really. UV. Oops, nope. Back out to you. UV. Project maybe. Nope. Which is the one I want. I don't really want to use the UV for this, if I'm honest, because UV is kind of a bad thing to use. Let me quickly just Google this. So prim UV. So it's like that. Then I could either use a point cloud or I can use a prim UV. Prim UV is going to give me something similar to what I want. What I'm doing here is I'm going to say, right, if it's like that, if it's inside, I'm just going to color it first as well. And I want to get the closest geometry position for that. And I want to move it there. So I'm going to say int here for primnum, like that, vector UVW. Right, now I need to go prim UV, 2, attribute name, is going to be position, bank, position, UV, no, trim num, and then VW, outs. Doesn't like that. Why don't you like that? Candidates int, string, int, vector. Yeah, that's what I've given you. Don't know why I have to use II like that. Oh, hang on. No, I don't want this. First, what I need to do is I need to do something called XYZ dist. I can't actually use that. What I need to do is I need to get XYZ dist. So I'm going to say float. And I think I don't even need to use scatter for this, because scatter might actually change it badly. So I'm going to say float XYZ dist, dist. So geometry is here. Position, and then I can say prim num, and then UVW. So I don't want float. Okay. And now I can use preview, prim UV, I can say attribute P. Is this based off of, you can see it's kind of pushed it in. It's pushed it in to where that was originally. I don't want it to update the velocity though. But we can try this. So then I do need that. I do need this. So let's copy this. Go back to you. That's the smoke sim. Go back to you. I'm going to say attribute wrangle. No, come on. Oh, pop wrangle. There's my pop wrangle. I used to love. There's my pop wrangle. Here we go. Pop you. Just going to paste it in there. I can then turn off you. Okay. Sets was. So we're actually just going to set the position completely. We're not going to set anything like the yeah input point. So it might actually induce some popping though. So stop and then stop. So what's the stop it's going to go out to? The first one is going to be the smoke collision. So and then out smoke. What do we call it? Out pop call. Okay. Let's see if that actually does anything. Do not like the looks of that. So it's literally setting that already. Not what we want, so it's setting the points permanently already there. Not what we want. Oh right, so that's going to be 0, and then that's going to be 1. Okay, hang on. I'm going to say none. Actually, no, I'm going to go back to stop. I'm going to say stop here. Oh, you. Oh, none. And I'm going to keep this to 1. All right. should start seeing more points than just that. What we can probably do here, honestly, is just kill them if we don't want them to be positioning to there, because it's getting the closest position, but it's not really liking that position. So we can do like a float, so that's the max distance it can go. This has to be 2 as well. I'm basically looking over here to see where, if their points start spawning in. They do. Not really what I want them to be doing. But unfortunately, well, we can just kill them if we really need to. What it's doing is it's saying we're not finding a position to actually put it there. I'm going to turn it back off. Not finding a position to push it to, which is really annoying. But what you can do is you can do something called min dist, which is going to end up being the same as the prim UV thing here. So I'm just going to quickly test that. I'm going to get rid of this. I'm going to test it. All right, fixing that kind of helped setting it like that. But let's just try the other one. So I can say min pos is going to be problem with this is that it might actually push it exactly close there. So to at position at P, it might actually push it back in there. So it's not really what we want. You, what's wrong with you? What do you like? Actually, hang on. Min pos doesn't. Yeah, it should. Good work. Okay, that looks like it's working as well. But you can also see that these are kind of sticking in there. Is not really what we want. I think they're not moving. Which might not really be what we want. Looks nice though, at least. Maybe we can agree on that one. Get rid of the pop up there. I do need the ground. Move. Ground can stay. So you got your cut. So if it is actually doing that, what we can do is, you know, it's impossible this way. But the other way is we get the position, we get the prim UV, sort of thing like that. So what we want to do is we want to say vector pos equals prim UV who p prim num UW. Then we want to also get the vector. We want to get the normal. So n is prim UV who p prim UW. That's wrong. The n here, that's going to give me the n attribute. This means that this needs to have an n attribute. So I'm going to say facet. I'm going to say post compute normals. I'm going to get rid of these. And then instead of this, we go pos plus, and then we're going to do a multiply of n times 0 0.0, so 0 0.01 sort of thing. And that's how you would do it with that one. That's going to give us a collision attribute, and it's going to slide. I can just turn this off. Actually, I'm going to keep the slide so that it slides on the ground. Okay. Now that's over with. Going to turn off this. I'm going to say dot import. Whoop. I hate it when it does this. OP. I'm going to say dot import. I'm going to say dot import fields really. It'll do the same thing. I want to whoop. Grab you. Grab you. I'm going to say. Pretty sure I can just say pop object one, right? And I can just say G particles. Ideally, be able to say particles. Doesn't look like it's going to give it to me though. So I might actually do need to actually use pop object. Oh, it's just pop object. Okay. Come on. Stop, keep going on like that. Pop. Hurry out. Pop object. Alright. And now we're going to get the pop up. And it's going to give me the collision for the ground. That's fine. But I'm going to turn off that. Out. Go over to here. We're going to get rid of a lot of the attributes. Attribute delete. What we can do. Gosh, why is it so slow? Everything's so slow today. I can use a clean. Why is it reading back in the volume? That's what I want to know. Why is it continually reading back in the volume? Stop. Stop. Far out. I'd love to know why it's deciding to read in these volumes. Hang on, where's my facet node gone? Let's compute. Thank you. Cool. And it keeps reading in from 44. Why? So, stop. Load from disk. Yes, you are loading from disk. Load. What? You shouldn't be reloading. I'm going to cut these. At you. Stop. Thank you. Don't know why it's cooking to frame 44 all the time. That's actually really, really annoying. You're always going to cook to frame 44. Why? Still reading in from frame 44. Let's turn you off. It's still reading in to frame 44. Okay. Cool. I am so glad that you're doing that. Right. Turn you back on. Up out. Why? Kill you. Stop. I really wish I knew why it was doing this. What I'll do, yeah, no, stop, is I will cache out this. Stop, out. Save the disk. That's really annoying. Oh look, it's almost midnight again. Now it's going to 15. That's fine. Good. A 44 again? I think it's this stop input field. Okay. Somewhere along the line, it's not. Let's go pop, stop, stop import. I'm going to say pop object. And hit reset on you. That. Cool. Why is it? Why? Okay. Hmm. Where is? Ask Gavin. Maybe he'll be able to give me a hand. With this blasted thing. Show me the velocity. Yep, it's got a velocity. Okay, cool. Alright, but why is it doing that? Go back to you. Let's go turn off you. You. Go. Yeah, I don't know why it's doing that. That's a real puzzler. Why I jump out and it immediately decides to go to frame 44. Hmm. Well, I'll post the file up later, so you can all see it later. You'll all get to witness the horribleness that it is. It's doing this. I don't know why. Okay, I'm just gonna save this. I'm gonna save this out. Pop source sim. Shut up, you. Yes, very good. But before I do that, gotta flip and cook again. What I want to do is I want to clean it. Clean. The hell's I'm laying down nodes, but it's not actually giving me the damn nodes. Clean. Give me a clean. Thank you. Cut. Open. Here. Paste. Clean. Let's take a look here. Stop it. Bastard thing. Right. I want to remove. I want to keep the points. Keep the degenerate primitives too. What do I want to remove in the attributes? So I want to keep the age. Age. I want to keep the D. D. I want to keep the PID. Yes, I want it. I want to keep the velocity. And that's pretty much it. Oh no, I want to keep life as well. Now, I think there was age. No, the age is already there. Anything else? Force, no. No. Nope. Okay. I'm gonna do. I'm gonna go back to you. I'm gonna say maybe we've got 5. Under you. Go to you. And I'm gonna hit sim. And we're gonna see. We're gonna see how it goes. I'm going to mute myself while it sims. Don't interrupt it, sorry. Also going to go to save, initialize. Just so that it reinitializes the sim from the start. See you later. Okay, am I happy with that? Yeah, that's pretty nice. Let's put some color to it. Change the ramp float to color and paste that back in. Paste. And there we go. See if there was any colors given to it from here. Net. You use the basic one. Okay. All right. Got that. You could use a lot more particles, if I'm honest. How many particles is there? About 7 million. It could use a lot more. So how many particles are here? How many particles are here? Not that many. We got like 10. Then we get a lot more. But what I want to do, go back to source here, because we only got that 2.8. I'm going to scatter it a lot more. Make it a bit more dense. And then I'm going to save that. gonna cut it there because it's enough for me. That's the file. There you go. Hopefully you like it. I don't know if I'll share it. Might do. That's yep. There we go. Won't do any more of the same because I'm already kind of maxing out my memory. Kill this one. How much memory am I going to say? Let's go to Windows. Where is it? Cache Manager. Which one's keeping it all? Cache. There, the top cache. Top cache is just going to fill up again, I think. Cool. It's going to take its time to do this. I think it's because I'm streaming that it's not liking it. So I'm going to stop it here. Yeah, actually I didn't finish looking at the side effects changelog, did I? Oh, come on, stop. Here we go, change. Connection. Doesn't show anything about collisions. I'm just going to hit clear all here because the sub cache obviously didn't really go down much. It's kind of gone down a little bit now. Not much. There you go. Go ahead and render that. Do whatever you want. You know, make it look pretty. Becky, got black body. Red. Infrared looks kind of nice. Off you go. How about it? I'm tired. It's almost midnight. I've been streaming for about 3.5 hours.